In this video, I'm going to explain you the concept of Gram-Schmidt orthogonalization process and following which the Qr decomposition. So before we get into the process, there are three important points that we need to know. The first point is that vectors Q1 through Qn are orthonormal if the product of Qi and Qj, two vectors, is 0 for I not equal to j, which makes it orthogonal, which makes the vectors orthogonal, and this product is 1 for I equal to j, which implies that the unit length for each qi, that is I equal to j, so that product is 1. The second point we need to know is when Q is a square matrix. By square matrix we understand that they have the same number of rows and columns. Then Q transpose Q, that means the product of the matrix with its transpose is nothing but an identity matrix, which also implies that Q inverse is nothing but the transpose of the matrix. The third very important point is the square matrices with orthonormal columns are known as the orthogonal matrices, and these will satisfy the previous condition Q transpose equal to Q inverse. So this idea of Q transpose multiplied with the matrix Q equal to identity matrix will help us in the QR decomposition. So let's first do the Gram-Schmidt orthogonalization process. We will go step by step, following which we'll do the QR decomposition. So the question that we have is find Q1, Q2, Q3. These are the orthonormal vectors from A, B, C columns. There are three columns given to us of A, and A is given to us as 1, 0, 0, 2, 0, 3 and 4, 5, 6. Therefore, I have represented these columns as A, B, C. So you can see that the first column 1, 0, 0 is A, second column 2, 0, 3 is B, and the third column 4, 5, 6 is C. The next part will be to write A, the matrix A, as a QR decomposition. And from the notes you would have read that QR implies Q is an orthogonal matrix, whereas R is an upper triangular matrix. So we'll do the second part, A equal to QR, later. Let's first see what is the Gram-Schmidt orthogonalization process. So the entire essence of the GS procedure is that at every step we find the orthonormal vector Q by taking vector A, B or C, that is the columns, and making it orthonormal to the previous ones. So what does this mean? So let's start. So let's find Q1, the first orthonormal vector. So we start with A, the column 1, 0, 0, and make it orthonormal to previous ones. However, there is no previous one involved in this. Therefore, this step becomes very, very easy. So we ensure that the vector has length 1. So we take A is nothing but 1, 0, 0. And then we also find the length of A, which is nothing but square root of 1 square plus 0 square plus 0 square, and that just turns out to be 1. Therefore, Q1 is nothing but vector A divided by its length, and the length is 1. Therefore, Q1 in this case just turns out to be vector A, which is 1, 0, 0. Right? So I denote this answer of Q1 as equation A, which we will be using later. Now let's try to find Q2. So there are two parts to Q2. First is the vector B itself, which is 2, 0, 3. And we subtract this with the projection of B bar, the vector B, on Q1. And we know from the previous videos and notes how to find the projection of one vector on the other. For that, we need to find the dot product of vector B with Q1, divide this by the length of Q1, and then multiply this entire ratio with Q1 itself. Right? So the task we have is to make B bar orthogonal to what we have, and what we have till now is Q1. Right? So I have written B on the right hand side, which is 203, minus, you find the dot product of B with Q1, and that turns out to be a value. You divide this by the length of Q1, which we have found previously as 1, and then multiply this with Q1 itself, right? So the dot product of B dot Q1 turns out to be 2. The length is 1, therefore 2 divided by 1 is 1, and Q1 itself is 1, 0, 0. So you have 2, 0, 3, which is vector B, minus the projection, which is 2 into 1, 0, 0. And once you do this subtraction, you end up with 0, 0, 3. However, here we have to keep in mind that this is not orthonormal. right? Therefore, we need to convert this answer 003, which we have obtained for Q2, into an orthonormal answer, right? The reason why we say that this is not orthonormal, because if you multiply this 003 with 100, you will see that they are not orthogonal, as the dot product is not 0, right? So what we'll do here in this step is this answer 003, which we were calling as Q2, let's call this some Q2 dash, right? Now in order to make this orthonormal, I'm going to take Q2 dash, divide this by the length of Q2 dash. Now I'm going to call this vector as Q2, right? Now Q2 dash is 003, and the length of 003 is 3 itself. So Q2 is nothing but Q2 dash divided by 3, and once I do that, you will see that this divided by 3 will give me 0, 0 and 1. Therefore, now Q2 becomes orthonormal, right? And I'm calling this answer as some equation B. So this is the second step. Now the third step, we go ahead with the same idea. So in the third step, now we need to find Q3, right? And that is nothing but the vector C, right? And the task is to make it orthogonal to Q1 and Q2. We subtract this C with the projection of Q3 on Q1 and the projection of Q3 with Q2. So I have written C dot Q1 divided by length of Q1 into Q1 minus C dot Q2 divided by length of Q2 into Q2. So I have plugged in the value of C, which is 456. I have found the dot product of C dot Q1, which is 4, divided by the length, which is 1, and Q1 itself, which is 100, minus C dot Q2, which is 6, the length of Q2, which is 1, so divided by 1, and 001. And once you find this answer, this turns out to be 050. Again, this is not this is orthogonal to Q1, Q2. However, this is not orthonormal. Therefore, I'm going to call this some Q3 dash. And then again, if you want to find Q3, you just take Q3 dash, divide by the length of Q3 dash itself, that divided by 5, this is the length of Q3 dash, this will be your answer. And then you can check that this is actually orthonormal, right? So I'm calling this as C. So what we have done till now is we have taken the matrix which is given to us in the form of A, B and C columns, and we have found the orthonormal bases for those columns. Now in the next part, we need to find the QR decomposition. So from the notes, you would have seen this equation A equal to QR, where Q is an orthogonal matrix with orthonormal column vectors. That means the matrix Q will just consist of Q1, Q2 and Q3, which we have found previously, and these will be the column vectors. Therefore Q, if you see here, it will be of the form 100, which is nothing but Q1, 001, which is Q2, and 010, which is nothing but Q3, right? Multiplied with R is nothing but an upper triangular matrix which is equal to which will make this equality true, right? So we need to find this matrix R because A is already given to us. So I have also plugged in the values of A. So our task is to find this matrix R. So let's see how we can find the matrix R. Now there are two methods by which we can find the matrix R. The first method is this particular method, which is given in the notes. If you have A equal to QR, you multiply both sides by Q transpose. So this becomes Q transpose A equal to Q transpose QR. And since this is an orthogonal matrix, Q transpose Q is nothing but I, which we had done at the start of this video. And therefore this RHS becomes I into R. And we know that identity matrix into any matrix just gives us the matrix, right? So R basically here is nothing but Q transpose A, right? So this is one of the methods which we can use, and this is a simpler method to use. So all you have to do is just find the transpose of the matrix Q. Once you have found the orthonormal columns, transpose it, multiply it with A, and you will get your R. The other method is the understanding method, where you have Q, where you view Q as a permutation matrix. It will always have be an orthogonal matrix which exchanges row 2 and 3 from R to give matrix A. So this could be a little difficult to understand, but this part is very easy. And once you do that, R just turns out to be like this, right? The check on R is that it always has to be an upper triangular matrix. So you can see I've marked the main diagonal 1, 3 and 5, and you can see that all the elements below this are 0. So once this is the structure of R, we know that it is right. Now let's see how these numbers in R have come about, right? So we need to check that R is actually right or not, right? So I'm going to use the previous equations. Okay, so I'm going to write A, right? The part A which we had found. So part A or value A from here, right? How do you get this value? This value will be nothing but this column of R multiplied with Q1, Q2 and Q3, right? So if you look at this matrix, the value of A here will be nothing but this column multiplied by Q1, Q2 and Q3. So therefore you will have 1 into Q1, 0 into Q2 and 0 into Q3. Therefore A is just nothing but 1 into Q1. So now if you look back at equation A, you will see that Q1 is A is nothing but 1 into Q1. Therefore this is right. Now how do we write B? If you look at B here, this will be nothing but the second column of R multiplied with Q1, Q2 and Q3. So I have written 2 into Q1 plus 3 into Q2 plus 0 into Q3. Therefore B turns out to be 2 into Q1 plus 3 into Q2. Similarly, if I want to write C here, it will be nothing but the third column of R multiplied with Q1, Q2 and Q3. So it will be 4Q1 plus 6Q2 plus 5Q3, and that is exactly what I have written. So let's see if we are right or not. So if you look at equation A, as I told you previously, A is nothing but 1 into Q1, therefore we are correct here. Now let's check if the equation for B is right. So from B, we have this Q2 dash is nothing but 3 into Q2. And also we have Q2 dash as B minus B dot Q1 divided by the value 2, which is the length of Q1 into Q1. Therefore 3Q2, which I'm substituting for Q2 dash, 3Q2 will be nothing but B minus 2Q1, right? Therefore B becomes 2Q1 plus 3Q2, which is same as this particular value. Similarly, let's see if this equation is right. From C, Q3 dash is 5Q3 and Q3 dash is also C minus C dot Q1 into Q1 minus C dot Q2 into Q2, right? And once you take all the factors here and substitute Q3 dash as 5Q3, you'll end up with this equation, which is same as that equation, right? So this is one of the checks that we can do. However, in the exam, you will not have to do that. All you'll have to do is find the vectors Q1, Q2, Q3 using the Gram-Schmidt procedure, and also then find the Qr decomposition. So in the next video, I'll explain you the Qr decomposition using another example.